Hey there, my name's Josh. I'm the third blogger in this triad of bloggers. So I figured I would start off this whole journey, I suppose, by starting off with something that it caught my interest last month. Haven't had really a chance to talk about it that much, but now that I'm going on YouTube, I figure, what the hey. So, without further ado, Abbott and Costello mathematics. So, Abbott and Costello tried to prove the fact that 13 times 7 equals 28. And they were able to actually prove it in their clip using this sort of mathematics. As you can see here, they first wrote out the equation as 13 times 7. Now, he goes on to explain, okay, well what's 7 times 3? That's 21. What's 7 times 1? 7. Add them together and you get 28. That's simple. They go further to prove this by deciding to divide it. They divide 7 by 28. Now the first thing they do is consider the 2. Now 7 can't go into 2, so they just drop that down here. And then they move on to the single 8. Now 7 goes into 8 one time. So, and then 8 minus 7 is 1. They put the 2 back down here, so now the number is 21. Now 7 goes into 21 3 times. So take 21, subtract 0, and you get 13. That also works. Which is a little weird considering that according to Abbott and Costello, 21 divided by 7 is not 3. And then they set up this really long addition problem to further prove that 13 times 7 equals 28. They actually wrote 13 7 times here. 1, 2, 3, 4, 5, 6, and 7. And apparently this all adds up to 28. They managed to do this by actually adding up each individual digit. So in other words, 3, 6, 9, 12, 15, 18, 21, adding up all the 3's, and then 22, 23, 24, 25, 26, 27, and 28 by adding up all the 1's. So there you go. Apparently 13 times 7 equals 28. So, using Abbott and Costello's newfound mathematical powers, I tried to actually rederive modern mathematics, just simple addition and subtraction, see what new results would be. And it turns out that this math is largely useless. Take, for example, the very similar problem 13 times 8. Now, just like Abbott and Costello, you first multiply 8 by 3, which equals 24. Then you do 8 times 1, which obviously equals 8. And then you just add the two results up, and you end up with the 32. But then consider the division for a minute. Now, this is the correct setup for the division problem, 8 divided by 32. And according to Abbott and Costello, the first step you have to take is try to divide the 8 by 3. No, that doesn't fit. So you're supposed to drag it down to use later. But then 8 also doesn't go into 2, and there's nothing to really divide into. So really, all you end up with is a heaping sack of fail. So the math itself might be flawed, though there are a few interesting patterns that I should note. I'd specifically like to talk about this rather large set of multiplication problems. They're just 13 times 1 through 9. And just a special side note, only some of these values will actually divide properly. Just 13 times 4, 13 times 6, and 13 times 7. I don't know why it worked out that way. I'm still working on that bit, but that's just how it is so far. I did notice something a little peculiar about this chart, though. I wonder if you can see it too before I explain it. I'll have to explain the pattern next week because I am out of time.